Skewness and kurtosis are used to test the normality of the data. In this video, you will understand the meaning of skewness and kurtosis and how the two measures differ from each other while testing the normality of the data. Skewness is the measure of the symmetry of the data distribution. A positive value of skewness indicates that the distribution has a greater tendency to tail to the right, also known as a positively skewed distribution or right-skewed distribution. In the case of right-skewed distribution, the mean will be greater than the median and the median will be greater than the mode. A negative value of skewness indicates that distribution has a greater tendency to tail to the left, also known as negatively skewed distribution or left-skewed distribution. In the case of left-skewed distribution, the mean will be less than the median and the median will be less than the mode. Skewness is 0 for a normal or a symmetric distribution. For the normal distribution, the mean, median and mode, all three will be equal to each other. Kurtosis is the measure of the shape of a distribution. The larger the kurtosis, the more peaked will be the distribution. The kurtosis is calculated and reported either as an absolute or a relative value. Absolute kurtosis is always a positive number. The absolute kurtosis of a normal distribution is 3. If the frequency curve has peak distribution more than the normal distribution or the tails are shorter than the normal distribution, then it is called leptokurtic distribution. In this case, the absolute value of kurtosis will be greater than 3. If the frequency curve has flatter distribution than the normal distribution or the tails are longer than the normal distribution, then it is called platykurtic distribution. And the value of kurtosis in this case will be less than 3. Skewness is the average of the third order. The formula used for calculating the skewness of a population is given as average of the cube of the deviation of each data value xi from the population mean mu divided by population standard deviation, or in mathematical terms, sigma xin cube of data values xi minus population mean mu divided by population standard deviation sigma divided by the number of data values n. Kurtosis is the average of the fourth order. The formula used for calculating the absolute kurtosis of a population is given as average of the fourth power of the deviation of each data value xi from the population mean mu divided by population standard deviation, or in mathematical terms, sigma xin fourth power of data values xi minus population mean mu divided by population standard deviation sigma divided by the number of data values n. The values of skewness and kurtosis both depend on the population mean and the population standard deviation. If you enjoyed the learning, then hit the like button and share the video in your circle and do subscribe for latest videos.